AI winning a Nobel Prize in physics. It's like, what? You sure they didn't get that mixed up? It sounds kind of crazy at first, right? But trust me, this is where it gets interesting. I mean, you've seen all the AI stuff blowing up lately, right? Like ChatGPT writing emails for people, AI art going kind of nuts online. And then there's Nvidia. They're practically running the show these days. But here's the thing. Most people have no clue about the wild connection between all of this. It's a story that goes way deeper than you think, all thanks to a Nobel Prize-winning discovery in, of all things, physics.
Yeah, it really makes you think about all the tech we just take for granted, you know? Nvidia's everywhere, and for good reason too. They're like the second biggest company on the planet now. And their GPUs are the engine behind this whole AI explosion. But the funny thing is, those GPUs, they weren't even meant for AI in the first place.
Right. They were built for gamers. Those hardcore players who need their graphics to be insanely good, like lifelike. You know, those crazy explosions and super detailed characters in those video games we love. That was Nvidia's whole deal back then. Who would have thought the same tech that gives us those awesome gaming moments would end up changing how machines learn?
It's almost poetic, you know what I mean? And it all goes back to this Nobel Prize winner, Geoffrey Hinton. Back in like 2009, Hinton actually tried to get himself a free Nvidia GPU for his AI research, and guess what? They said no.
Seriously, they turned down the guy who'd win a Nobel Prize for the very thing that'd make them billions. That's got to be one of the biggest oops moments in tech history, right?
You can say that again. It's kind of hilarious in a way. But even back then, Hinton, he saw what those gaming chips could do for AI, even if Nvidia didn't. He was way ahead of everyone else, a total visionary. And his work, well, it basically showed the world and Nvidia too what their own technology was truly capable of. It's like he handed them the missing piece of the puzzle and boom, everything changed.
Talk about a billion-dollar light bulb moment. They were all about gaming, and then it hit them, this thing we built for gamers.
Yeah.
It can change how machines learn. So how did this even happen? What's this whole artificial neural network thing? It still sounds kind of sci-fi to me, to be honest.
Okay, so think of it this way. Imagine you're trying to teach a kid how to recognize a cat, right? You show them pictures, point out the ears, the whiskers, all that. And their brain, over time, starts to pick up on the patterns, what makes a cat, you know. Artificial neural networks, they kind of work the same way. By looking at tons and tons of data, they learn to recognize patterns, just like our brains.
Okay, that makes sense. But I remember hearing about these early networks, and they weren't exactly, you know, winning any awards. Like, were they basically toddlers trying to recognize a blurry picture of a cat?
Exactly. They could handle the simple things, but anything too complex, and they'd fall apart. But then, in the 80s, everything changed. This guy, John Hopfield, another big name in this Nobel Prize story, made this huge breakthrough. He figured out how to make pattern recognition in these networks way better using, get this, physics.
Hold on, physics. So we're going from brains to computers to cats, and now physics. How does that even work? It seems like we're all over the place now.
It's not as crazy as it sounds, I promise. Think about it. Physics is all about figuring out the basic rules of how the universe works, how everything ticks, right? And building a machine that learns like a brain. That's a pretty fundamental problem, wouldn't you say?
So it's like he taught those networks to see through the blur, find the cat hiding in the mess. That's amazing. But earlier you mentioned these early networks were good at, like, recognizing patterns, but not so good at predicting things or making something new. That's where Hinton comes in, yeah.
Exactly. Hinton took what Hopfield did and, well, he kind of flipped the script. He added something called hidden layers to these neural networks. It's like giving AI a subconscious, you know.
A subconscious? Okay, now we're going full-on sci-fi, aren't we?
It's not that out there, I swear. Think of it like this. Imagine a cat hiding behind a curtain. All you can see is its tail, right? Switching back and forth. Now with Hopfield stuff, the AI could probably figure out, hey, that's a cat's tail. But with Hinton's hidden layers, it can take it a step further. Now it can predict, hold on, there's got to be a whole cat attached to that tail, even if I can't see it all. It's like these hidden layers let the AI make a guess, go beyond just what's right there in front of it.
Wow. So that changes everything, really. Is that like going from just recognizing something to like actually understanding it, at least a little bit? And this is the foundation, the basis for all the crazy stuff AI can pull off now, like ChatGPT and DALL-E.
You got it. ChatGPT spitting out those crazy good responses, DALL-E making those wild images. It all goes back to Hinton's hidden layers. He's the one who let these machines not just see stuff, but like actually imagine things, create. And here's where it gets really wild. Those hidden layers, they come straight out of physics. Imagine a ball rolling down a hill, right? It's going to end up at the bottom. Hidden layers, they help the AI find those low points in the data, showing them the most likely answers. That's physics, making AI smarter than ever.
That's so cool. All right, so we've got brains, computers, cats, even a little philosophy thrown in. But why a Nobel Prize in physics? Why not, like computer science or something?
Yeah, that's the million-dollar question. A lot of people are wondering about that, even scientists. But here's the thing. Deep down, at their core, these neural networks, they're built on physics.
Seriously, break that down for me. How can physics be that important for AI?
Remember those 3 branches of physics I mentioned earlier, biophysics, statistical physics, and computational physics? They're all in the mix here. Biophysics, that helps us understand how brains learn in the first place, which is what we base these whole artificial neural networks on. Then there's statistical physics. That gives us the tools to look at huge amounts of data and find those hidden patterns that AI uses to learn. And lastly, computational physics, that's the horsepower that lets us crunch all those numbers and actually run these crazy complex models.
So it's like physics gives us the blueprint, the tools, and the engine for AI.
You got it. It's the invisible force that makes it all happen. Without these physics principles, none of this would even be a thing.
Mind blown, for sure. Okay, so this Nobel Prize is totally deserved, even if it's a bit out of left field. But for our listener out there who's probably thinking, this is wild, but what does it have to do with me?
That's what it's all about. This isn't just some science experiment. It's changing our lives right now in ways we don't even realize. Every time you ask Siri to find you a good pizza place or use your face to unlock your phone, that's those physics-powered neural networks at work.
So it's way bigger than just cat pics and robots answering questions. This is about pushing the limits of what we know and tackling some of the world's toughest problems.
Exactly. And it's not just in some lab somewhere. This is everywhere. Self-driving cars, physics-powered neural networks, and we're just getting started.
It's kind of mind-boggling to think where this could all lead with this kind of tech at our fingertips.
And the potential payoff is huge, too. There was this McKinsey report. It said generative AI, just that one type, could add something like $4.4 trillion to the global economy every single year.
Whoa. Yeah, okay, that's a lot of zeros. But for all the good stuff about AI, there's some serious fear out there, too, right? People worried about losing their jobs, AI getting too smart for its own good, even those sci-fi movies where the robots take over. It's that whole, with great power comes great responsibility thing, you know?
Yeah, it's a lot to think about, for sure. This power that AI has, it comes with, a responsibility to make sure it's used for good, for everyone.
Definitely. It's a conversation we can't ignore, as a society. This whole thing, from those first neural networks to a Nobel Prize in physics, it really shows how connected everything is.
It's like that Steve Jobs quote, right? You can't connect the dots looking forward, only looking backward. And this Nobel Prize is a perfect example. AI and physics, they seem so different, but when you look back, you see how they're totally intertwined.
Exactly. And that's what makes this so exciting. It makes you think, what other connections are out there just waiting to be found? What about those fields that seem totally unrelated? Maybe they hold the key to the next big thing, Totally. Even the article we're talking about today brings that up. Some people think this prize should go on to mathematicians or computer scientists. And their work is obviously huge for AI, right?
Oh, absolutely. But the real lesson here isn't about who gets the trophy. It's about realizing that the best, most innovative stuff, it happens when different fields collide. This Nobel Prize, it reminds us that the biggest discoveries come from thinking outside the box, pushing past the traditional boundaries.
It's like a choose your own adventure for scientists, right? Just when you think you know what's going to happen, bam, a whole new world opens up.
That's science in a nutshell. It's not just a straight line, it's like a web that keeps growing, with every discovery leading to new questions, new ideas, new possibilities.
So as we wrap up this deep dive, what's the one thing you want our listeners to walk away with?
Never stop being curious. Don't be afraid to explore those weird connections, those things that make you go, that's interesting. Because the next big breakthrough, it might be right under our noses, just waiting for someone to connect the dots.
And hey, that someone could be you. Thanks for joining us for this wild ride into AI and the surprising physics behind it. Until next time, keep exploring, keep learning, and keep on diving deep.